So now come to CPU scheduling algorithm. Okay. So there are several types of CPU scheduling algorithm. So I will start with first come first serve or FCFS algorithm. So please listen very carefully because CPU scheduling algorithm is a very important topic for GATE exams. They generally ask questions either from memory management unit or from CPU scheduling algorithm, and also from some time process state diagram. So these three topics are very important. Process state diagram I have completed, but still previous year's questions are yet to be solved, but don't worry, I'll solve it soon. And now I am teaching you CPU scheduling algorithm. So please concentrate, please have a full concentration on what I am teaching you right now. Okay. So first come first serve algorithm. So as the name suggests, first come first serve algorithm, it means here the process which enters first into the ready queue will finish first. It will execute first and will finish first. Here there will be no preemption. I told you the meaning of preemption in the last video. Here it will be more clear to you. Okay. Just see this diagram. It's a part of process state diagram. It's incomplete process state diagram. So here you see the process, movement of process from new to ready, ready to run, run to terminated. Here you see I have not drawn an arrow from run to ready. Here there is no arrow from, one second. धीरे बोलिए थोड़ा धीरे. Okay, fine. So here this arrow from run to ready is not present. Here only new to ready, ready to run, run to terminated. So this arrow is not present. So this arrow indicated what? This arrow used to indicate preemption, but here preemption is not happening. It means what? When a process takes a CPU, it releases the CPU after completion of its whole task. Okay, after completion of its task, it will release the CPU. It will not release the CPU in the middle of its execution. Okay. So it's better to give you some examples of some numerical examples, then I think it will be more clear to you. So let me give you one example. Okay, I think I should rub this. You just note it down. Okay. So assume, this is a numerical example. Assume there are several processes whose arrival time and burst time are given. Okay. The processes are P0, P1, P2, then okay, let me start with P1. Okay, P1, P2, P3, P4, then P5, and arrival times are 0, 1, 2, 3, 4. 1, 2, 3, 4. And burst time means CPU usage time 4, 3, 1, 2, 5. 4, 3, 1, 2, 5. Fine. So here what will happen, you see. Is it visible? Okay. It's a queue. Okay. Here first, one thing, just listen. This arrival time 0, 1, 2, 3, 4. Don't compare this time with the time of your clock. Okay. Arrival times here, it indicates that P1 enters first. at 0th second, P2 enters second at 1st second. Okay, don't compare this time with the usual time of clock like 11:15 a.m., 11:15 p.m. Okay, so now here process P1 arrived first. So process P1 will arrive first at 0th second. Since it's a non-preemptive scheduling, then process P1 will complete its task, then CPU will be given to other process. So process P1 will complete its task up to 4 second, 0 to 4 second. Okay, now the task of P1 is completed. Now the CPU is given to P2. Why? Because after P1, P2 has arrived, not P3. After 0th second, you can see 1 second is there. It means what? P2 has arrived. So now CPU is given to P2. And now P2 will run for 3 seconds. So 3 seconds, it means what? P2, it will be 4 plus 3, 7. Okay. Burst time of P1 is 4 seconds, 4 minus 0, 4. And burst time of P2 is 3 seconds, 7 minus 4, 3. Here you can check it. Okay. And after the completion of P2, P3 will arrive. Okay. So P3 will arrive. So burst time of P3 is just 1 second. So after 1 second, P3's task is over. So here P1 task is over, P2's task is over, P3's task is over. Now CPU will be given to P4. Why? Because just after P3, P4 arrived. That's why. So burst time of P2 is 2 seconds. So here it was 8. 8 plus 2, 10 seconds. So P4 executed from 8 seconds to 10 seconds, means for 2 seconds. 10 minus 8 is 2. And at the end, after P4, which process arrived? P4 is also finished. After P4, which process arrived? After 3 seconds, you can see there is 4 seconds. And 4 seconds corresponds to P5. So here it will be P5. And P5 will run for 5 seconds. It means what? 15 seconds. So this representation is called Gantt chart. Gantt chart. Okay. So with the help of this representation, we can find out the actual waiting time of each processes, as well as turnaround time, as well as average waiting time, as well as average turnaround time. Okay. So let's calculate the turnaround time first. Here P5 has also completed its task. So just see here. First CPU was with P1. Now CPU switched to P2. So the switching of CPU from one process to other process is called context switching. Okay. The switching of CPU from one process to other process is called context switching. So here how many context switching happened? 1, 2, 3, 4. So here number of context switching is equal to 4. Don't consider this one and this one. Okay, because here there is no context switching. Here the CPU is given to P1 and now it is switched to P2. So you will count it as one context switching, 1. Then from P2 to P3. Second time the CPU switched from P2 to P3, 2, then 3, then 4. 4 context switchings are there. Okay. And also there are some points regarding context switching, is that okay, I will tell it later. So let's complete turnaround time. So what I told you about turnaround time, it's what? Completion time minus arrival time. means what? The amount of time that a process spent in the queue is the turnaround time. So here before turnaround time, let's write the completion time of all the process. What's the completion time of here? P1. The completion time of P1 is 4. Okay. What's the completion time of P2? P2 completed at 7 seconds. 7. What's the completion time of P3? 8. P4? 10. P5? 15. So these are the completion times of each processes. Now, let's calculate turnaround time. Okay. So what I told you about turnaround time, the amount of time spent by a process in the queue. Okay. So let's calculate it. So what was the formula of turnaround time? It was completion time minus arrival time. Completion time minus arrival time. So let's calculate the turnaround time for P1. So what's the turnaround time for P1? Completion time is 4 minus arrival time. Arrival time is 0. 4 minus 0 is equal to 4. Okay. Completion turnaround time for P2 is 7 minus 1 is equal to 6. Completion time of P3 is 8 minus 2, not completion time. Turnaround time of P3 is 8 minus 2 is equal to 6. Then for P4, completion time minus arrival time. 10 minus 3 is equal to 7. Then for P5, 15 minus 4 is equal to 11. So these are the turnaround times of each processes. Now let's calculate the waiting time. So what I told you about waiting time means what? The amount of time spent by a process in a ready queue before it got scheduled. For example, I give you an example. You see here P2. Here P2, the arrival time of P2 is 1, but P2 got scheduled at 4th second. It means what? P2 arrived in the ready queue in the 1st second, but in order to get scheduled, in order to get the CPU, it waited till 4th second. Okay, it means what? P2 waited for 3 more seconds. It came at 1st second, got scheduled at 4th second. So what is the waiting time of P2? 3 seconds. Okay, so it's so this is called waiting time. And what's the formula of waiting time that I told in the last class? It was turnaround time minus burst time. Okay. So what is the turnaround time of P1? 4. What is the burst time for? 4 minus 4 is equal to 0. So here you can notice the waiting time of process P1 is 0. Why? Because just after entering into the ready queue, it immediately got scheduled. It didn't have to wait. Okay. So that's why the waiting time of P1 is 0. Now let's calculate the waiting time of P2. From here you can say that P2 arrived at 1st second, but it got scheduled at 4th second. So what is the waiting time of P2? 4 minus 1 is equal to 3. Okay. And from the formula, you can also write it as what I said, turnaround time minus burst time. What is the turnaround time? 6 minus burst time. 6 minus 3 is equal to 3. From here, you can also find. So now let's calculate the waiting time of P3. What is the waiting time of P3? As I already told you, you see, P3 arrived at second, okay, but it got scheduled at 7th second. It arrived in the ready queue at second at t is equal to 2, but it got scheduled at t is equal to 7. It means what? For how much time P3 waited? 7 minus 2 is equal to 5. Or from the formula, you can write it as turnaround time minus burst time. 6 is the turnaround time and 1 is the burst time. Okay. So what's the turnaround time of P4? P4 arrived at t is equal to 3 seconds, but P4 got scheduled at t is equal to 8 seconds. So what is for how much time P4 had to wait? 8 minus 3 is equal to 5, or we can say it as turnaround time minus burst time. What is the turnaround time? 7 minus 2 is equal to 5. Okay. And let's calculate the waiting time of P5. What's the waiting time of P5? The waiting time of P5 is turnaround time minus burst time. 11 minus 5 is equal to 6. And also you can say that P4 arrived at t is equal to 4 seconds, but P4 got scheduled at t is equal to 10 seconds. So how much time? So sorry, P4, I'm talking about P5. So how much time P5 waited? 10 minus 4 is equal to 6. So from your intuition, you can calculate, and also from the formula, you can also calculate. Okay. So I have calculated the turnaround time and wait time of each process. So what is the average waiting time? Because mostly in the exam, they ask questions like average waiting time or average turnaround time. So what will be the average turnaround time? So average turnaround time will be, you just sum up all the turnaround times of each processes and divide by number of processes. Okay. So here, turnaround, what are the turnaround times? 4 plus 6 plus 6 plus 7 plus 11 divided by how many processes are there? I guess 5 processes. Yes, 5. So what is the average turnaround time? 10, 16, 20, 6, 12, 16, 23, 34 by 5, or it's approximately 6.8. 6.8. And what is the average waiting time? Is it visible? Average waiting time will be just sum of all the waiting times. 0 plus 3 plus 5 plus 5 plus 6 and divide by total number of processes. 5 plus 5, 10 plus 3, 13 plus 6, 19 by 5, which will be approximately 3.8. Okay. So these are average turnaround time and average waiting time. Okay. So sometimes they may ask question, what is the normalized turnaround time and normalized waiting time? So in that case, what you will do, just listen carefully. The turnaround time that you are getting, just divide it with the corresponding burst time. Okay. For example, so here I write the formula. Normalized turnaround time is equal to turnaround time of Pi is equal to turnaround time of Pi. First calculate the turnaround time divided by burst time of Pi. Okay, and also if they ask the normalized waiting time of Pi, you will do? The formula is waiting time of Pi divided by burst time of Pi. Simply just here waiting time, normalized waiting time of Pi is equal to waiting time of Pi divided by burst time of Pi. So that's all about first come first serve CPU scheduling algorithm. So basically the main disadvantage, actually this algorithm is easy to implement, but the main disadvantage of this algorithm is that you see here the process which are coming later, like P2, P3, P4, and if they have shorter burst time, I mean to say that the process which are coming later and they have shorter burst time, even though they have shorter burst time, but they have to wait longer. Are you getting? So here what is happening, the process which has sometimes the process which has shorter burst time may have to wait longer. Here you see P3 has shorter burst time, but P3 has to wait for 6 seconds. But P1, P2, they have longer burst time, but P1 has the longer burst time than P3. P1 has the longer burst time than P3, but P1 has to wait for just 0 seconds. Okay, so this is the main problem of this first come first serve algorithm. So actually first come first serve algorithm is suffering from convoy effect. Okay, that I will tell you after some time.